Hello everyone and welcome to this new CATIA Design Talk, the webinar series where we explore the latest trends, tools and techniques in industrial design and engineering using CATIA, the world-leading software for product development and innovation. My name is Fabio Ballari and I have the pleasure of hosting today our CATIA Champion Tomislav Solina and our expert from R&D, Edouard SUTRE today. Hello guys.
Hello.
Hello.
So together we will talk about the CATIA Visual Scripting app by showing a very interesting use case which applies Raindrop on a car model. So hello Tomislav and Edouard, first of all, can you please introduce yourself?
Of course. So hello everyone. My name is Tomislav Solina. I'm using the SO products since very long time. And most of the time I have spent on modeling tools where I was professionally working as a concept modeler in the automotive sector. I was covering sub-D for with imagine shape, Bezier tools, reverse engineering, but my passion was always parametrical modeling. So either basic GSD or advanced templating techniques supported even with VBA or .NET as scripting tools, and some of my templates can be seen on my YouTube channel as well. And recently I had a chance to work with the SO system on generative design, and now as Visual Scripting is available with a native client, it was the time to deep dive into Visual Scripting as well. So, which is Visual Scripting itself is a technically next-gen modeling tool, and I simply couldn't wait to use it. And beside modeling tasks, I recently was covering 3DX platform administration tasks, 3DX implementation, supplier integration, support, and I served as a link between my previous company and the SO support team. And I'm currently available on the market. So guys, if you like the presentation. And I'm honored to be listed as a CATIA champion in 2017.
Very good. Edouard, what about you?
So hello everyone. So I'm part of Dassault Systems and CATIA R&D organization, and I'm an expert on CATIA Visual Scripting application. My role is to help the development team to deliver new features and also to communicate with you guys as a community of users to understand your needs. And it was a great opportunity to work directly with Tomislav as a CATIA champion, to have this kind of relationship, to understand his feedbacks about the adoption of this application. And we are really curious to see the results of Tomislav.
Yeah, so Tomislav, as you said, you reached out because you wanted to test our latest technologies. And actually, you have produced a very interesting use case, which is more than just a talk, but clearly a masterclass. Let's have a look at it.
Thank you, Fabio. So this is my raindrops project, where I try to create raindrops on the surface. But let's go through the presentation and see the motivation and so on. So first of all, I will have a little agenda for you. So we will see a couple of real-world examples. I will tell you why I was trying to create this, and we'll speak about some optimizations like a drop flow, duplicates handling, or shape optimization. As well, we will have some custom features, because this we can do as well. And of course, one of the big topics is error handling, which we will discuss in detail soon. And I will show you one example where basic drops were created. Of course, basic drops are much simpler than the real drops, because in order to create a very interesting result, we need 10% of the time, but to finalize it, we need to spend other 90% of the time on the project. And of course, at the end, I will show you a couple of results we created with this template. So here are a couple of real-world examples. So you can see here the picture of technically my vehicle that I took outside, and simply took a pictures when the light rain was dropping, simply to see how the raindrops are behaving when they are laying on the surface, or when the surface starts to flow, when the rain starts to flow on the surface. So here you will see as well that these lines are forming, and this is something that I wanted to recreate. As well, you will see that the rain is always, or technically, falling from the top, so it always is in Z direction, but line flows are then happening on the side surfaces. So we'll see how to do this. And so here is my motivation. Motivation is simply I wanted to explore the possibilities of this tool because this tool promised a lot, and I simply wanted to be part of it. And main usage of this tool from my perspective is either to rapidly develop complex shapes for eventually even production, but even more important is to create marketing pictures realistic as possible. And visual scripting gives us possibility to work directly with the surfaces that are created by different teams. So we can work on existing surfaces. We don't have to prepare them in specific way. We can directly use them. And with this, we can come towards the example itself. So in this case, first of the topics is drop flow, where you can see that the lines are actually generating quite naturally, because when the raindrops are falling, they fall somewhere, and then afterwards they create such line. And you can see as well the line is not really straight. They are having this little wave because surface is not perfect, and we wanted to recreate this with the template itself. Then here was of course, the next problem was when you're generating elements, you generate the lines, you generated the drops, and they start to overlap. So one of the things was either to join them and reuse them as something even more complex, or simply to remove them from such scene. And in this case, I was trying to remove them. For that, I was using simply the equal script objects. So technically, we can create own script, and we can attach it into the graph, connect it with inputs that we need, and generate the outputs that we as well need. And inside of this block, EKL in this case was simply calculating the distances between the elements and removing the elements that were too close. Then after this, there was another optimization necessary, and this was optimization of the shape. So in this case, shape is optimized in a way that raindrop itself is not dropping as a sphere on the surface. It's more like a squeeze sphere that is even trimmed from the bottom. And this is exactly what we try to recreate here with some fillet on the side, and we have back surface as well. Why this? Because for rendering, it was necessary to have this back face in order to have more realistic reflections. And as you can see here, we have the surface, technically 3 faces only, which then spores the performance by renderings afterwards. But we can talk about that later. Couple of words about custom features. So one of the custom features was exactly this script that we have shown earlier. And another ones are either the simple things where we are formatting things in the way that we need them, or we can even put a big chunk of functionality within one block so that we easily can reuse this block for different purposes. And for instance, we can use them to filter out overlapping elements. So we can generate only one block, attach several inputs, outputs, and we can have a functionality hidden inside, which is doing exactly that what we need from it.
We are quite impressed. In fact, you used user operator creations to create your own building blocks, right?
Correct.
Quite impressive, finally.
Correct, because even though the visual scripting is offering a broad set of the tools available, in some cases, project-specific elements, of course, cannot be created as a default functionality. And this is something that we can mask, or we can wrap into custom user operators, which then we can even save it in the library and reuse for further projects afterwards. After that, we have a very important topic, actually, especially as we're here working with huge lists of elements. There is one aspect of errors, which then are happening, and we get blocks in the red color, and technically the calculation stops. And this is the completely true for instance, for GSD. So generative shape design, if we get an error, this technically means showstopper. We have to fix this error because before we continue with execution of the subsequent elements. While with visual scripting, we don't have to go this path. We can technically go in the way where we are actually handling this element. So if elements get broken, we can filter out elements that are not in error and simply continue using them. But we can as well make a second branch where we are simply handling this error by simply adjusting parameters, or we tune them in different way, but and join the groups afterwards. So technically we can avoid the errors and we can continue executing even though errors were happening. We'll see even some of this in the live example. So here we will speak about the example. I will show you how to create it. So these are first couple of steps that we will create. After that will come much more. But before we start with the example, here you can see a simple preview how this graph itself looks, and this is something that we will recreate. How this works, let's see it in the video itself. So here is the video. So first of all, we have to create a couple of inputs. In this case, we can simply select the surface that we want to use. So we select it from the 3D directly through this interface. Then we can create additional parameters that we will use for the calculation of the script itself. So we will need the length. They will length parameter, which will define the size of the raindrop, which we can then use after we finish. We can still use it in the CATIA 3. We will see that later. We will need as well amount of the drops that we initially generate, and then we can start building the graph. So first thing that we are creating will be one extremum, where we simply want to define the top point where the element are where we want to define one point so that we can have a plane through it and we can project the surface. So in this case, we'll project the whole sphere on this plane as a silhouette, and we will of course close it. So this is exactly what we are doing. You can see here that I'm not updating the graph itself by every comment. This is simply for performance reasons, because in some cases, some operations take longer. Of course, these are basic first operations. It would calculate relatively quick, but later it might be necessary to have them separately. So you can see this little update button on the top that will then generate results for us when we need it. So this created the silhouette as a surface. On this silhouette itself, we will use we will parameterize this projection, and we will create the points on it. So you can see that we as well publish these main parameters so that we can access them from the graph directly without actually selecting the main elements by connecting them with the line as it was just done with this projection. So first thing is to create the sampling. So the points are created on this flat surface. They are back projected to the sphere, and now we can of course deactivate elements that we don't need or hide them. And now you can see that these dots or the points are created only on the upper part of the sphere because we've been projecting them only in that top direction. Why we did that? Simply because rain is dropping from the top and then will start to flow down. So about this flow, we are creating here two lines that will define the plane. So one is the line normal to the surface, another one is line in the Z direction. And if we update this, we'll see that there is a plane created through these two lines, which if we intersect with the surface will give us the direction in which, for instance, the drops can flow. So we will do that. And you can see here that unfortunately it happened that some intersections are happening on the areas where we don't want to have them. But we can even handle this with, for instance, near, where we select only the only the lines that are intersections only that are on the side where the surface is, where the points were created. So all other lines, all other intersection objects were simply removed. Then we can split these curves by points, the original points, originally projected points, and we will get the upper limit from which the drops are actually starting. Of course, in this case, the orientation was wrong, but we can simply switch it to other side. Regarding the lower limit, we will again split the curve one more time. We will split it with a curve, with a point on curve with ratio. So by default, this is on 50%. And if we put it on the same curve as on the same input, we'll get the point exactly on this curve on 50% of that curve. This is, of course, not really realistic, and we want slightly more than this. So we will create a function that will handle how these elements are actually distributed so that we don't have the same length for all the elements. So we will create simply one sequence, one function, and the sequence will give us possibility to attach this again to our lines so that we know how many elements we actually have to create. It will generate us percentual values, which you can see here now, move from 50% to different points. And technically, we can now split this. With this graph, we can then play as well in order to with this function graph, we can play in order to shorten or extend this curve, so we can define the position of the points, fine-tune it afterwards. So this will give us then possibility to split it, and as you can see, only the upper part of the curve left we kept here. So this we'll use now to create the additional points that are going to flow with this line. So in order to do this, we will use the sweep. And in order to define how many elements we need on this sweep, we will simply divide the length that we currently measured with the length of the curve with the size of the raindrops. And after that, we can see that the elements are prepared for calculation. We have some error that we can handle in this case, but we just have to connect it with correct set of parameters in this case, and we will see that the sweeps itself are created in this way. So now we have amount of elements that we want to apply here, and we will use again surface sampling on each of these elements. So as you can see here, I'm not handling one element. It's not created one sweep here. It's create a list of sweeps on which we are performing specific operations. And in this case, we simply created this number of elements on each of these surface samplings, and we will project it back to the surface, and you will see the result in the second. So here is some error again, which we will handle in a second. What is expected here? It's expected that we have sweeps. On these sweeps, the points were projected, and then as they are projected back from that pipe back to the surface, they will give us effect of the line that is not straight, but it's slightly wavy, which is more realistic than the line that would be straight. We will see that in a second. So here are a couple of options where we are tuning this list, filtering out the error elements, and reapplying them back to the surface. So projection is again not completely successful. Reason in this case is simply because some points are not possible to project on the sphere, or not possible to project on the surface. And in this case, this is not a showstopper. We simply don't need these points, and we will simply use the remove error and remove these elements from the further calculation. On this element, we can then apply first spheres, and we will have first raindrops technically already created on the surface. And if we were using classical tools, we would have problems with these elements that are not actually projectable. But in this case, we were able to simply overcome this issue in very intuitive way. So now you can see the spheres were created, but their size is incorrect. We will simply replace this with a parameter of the size, with the size of the raindrop. And now we are simply not happy that all of them have same size, because this is again not really realistic. In order to overcome this issue, we will simply count amount of elements. We will generate a random number for each of them, multiply it with the size of the raindrop by simply selecting the raindrop parameter, and we can reconnect the same back to the previously created sphere. And now you can see already we have the spheres. So we have a basic examples, which is already here, which is generating these raindrops on the surface, which then we can group and reuse later in the realistic objects on realistic surfaces that we want to apply this template to. So only necessary step afterwards was to publish the geometry that we want to keep, and after that we have it directly here in the list. After that we can play with the parameters. So we will change the number of the lines that we are generating here. We will as well change the size of the drops, and you can see we can in very easy way replace even the surface, but we can generate different results in a very swift fashion, and technically we can use this for rendering afterwards.
Wow. Absolutely stunning work, Tomislav. Well, with this level of expertise on display, I have no doubt you will in high demand. So don't expect to stay in the market for long.
Thank you.
It shows also very well the capability of the app, and with this full demonstration, I hope it helps user to better understand visual scripting. Edouard, what do you think about this demonstration?
Again, I think we are quite impressed, and also it's always interesting, to see our users and what they are capable to do with this kind of application. And I think, Tomislav, I hope everyone was able to follow you. I think you were explaining a lot of things really quickly, but really interesting stuff. I think you are using the application really in a good way. You are using the immersive search, you are using the quick access menu. In fact, we are quite proud also to see that what we are developing is used this way with you. And also we received your feedbacks. So we will try to improve the solution this way. Again, it's a pleasure to have this kind of collaboration between Dassault Systems and our users.
Thank you, Edouard.
Okay. And now I want to see the result.
Yeah.
Yes, absolutely. This is the thing that is still missing here. So here are a couple of results. So this is one of the first results where drops were simply applied to glass sphere in order to see how the reflections are behaving, to fine-tune the flow, to fine-tune the elements when they are on the back side of the surface. And technically, this result was quite interesting. And then, of course, it was necessary to go further. So then these raindrops were applied to more realistic surface, in this case some kind of motorcycle tank, where we can see again very interesting highlights on the raindrops when they are applied on the surface. And with this going, we went even further, where we applied it, for instance, on the whole car. And here is a detail of this work. So you can see the drops applied on different type of surfaces, on metal surfaces, on the glass surfaces, with effects on both of them, which then guides us towards more complex results, because this is a basic rendering, but we wanted, of course, more realism. So in order to do that, the proper background, proper environment, proper lighting was selected, and raindrops were, for instance, applied on the whole car, and the whole car was then rendered. And here you can see the result. I consider this result very, very realistic in this case, and it gives us in very swift fashion possibility to apply such template on very complex shapes.
Yeah, actually, what happened? You just share your template to one of our IPS, Felix Rockel, and he just had to apply, not to rebuild everything, just applying on his own surface. That's the beauty of and the power of this tool.
Correct, because Felix simply had a more realistic example on which we could apply this geometry, and it was simply a great pleasure to work with him in this way, because we could exchange the data through the platform in a very easy way, where he could directly access the data, and we could apply my template on his data, and we could fine-tune it in order to achieve this result.
That's great. So thank you, Tomislav. Thank you, Edouard. So I think now it's time to open the Q&A session. So while you're showing again some picture of the car, we can answer to the audience question. So you just have to type your question in the comment tab and we will answer to them. Don't be shy. And take benefit of those two experts with us today, which is pretty unique. I think question will be displayed as soon as they will arrive. Okay, we have a first question. Was it easy to learn and use CATIA Visual Scripting?
Was it easy? At first glance, it was necessary to get used to new user interface, where instead of building the tree, you're building the graph. But after that, technically all the functionality that was missing in GSD, it was simply available here, and it was quite intuitive to access the commands. So technically it goes very fast. The learning curve goes very fast.
I think yeah, it's really good feedback, especially because you have strong skills in traditional CATIA applications and also knowledgeware. So definitely for us, it's perfect. Huh?
This flexibility of the tool was simply amazing, and the way how you can handle the big lists of the objects, it was simply a reason to say, oh yes, I want to use this.
Okay.
Any other questions, guys?
Where can I find some tutorial or example? I think this one is already tutorial first, but maybe you have an additional tutorial.
So if you want to discover and to know more and also to access tutorials, in fact, we have a dedicated swim community open for everyone. And in the wiki section of this community about generative design or visual scripting, we have lots of tutorials, data samples. Maybe Tomislav, you could put your own models after this session in this community too. And also this community is here to let the users talk and share some best practices and tutorials. So it's open to everyone. We can put the link.
Yeah, people has to type on Google or whatever other browser, CATIA Design Community, is it right? Or CATIA Visual Scripting Community, how to access easily?
Yes, you can type it, or I will put the link in the comments.
Okay. Can we use different scripting language for, can you use a different scripting language than AKL?
Edouard, would you like to say about this topic?
Yeah, because I know I think you also asked me this same question, Tomislav.
I asked you many times, yes.
So in fact, yes, in visual scripting, it was possible to also script your own operators using the Dassault Systems language, the EKL language. But we switched to the 24x release this week, in fact, and we now have the capability to script also with the Python language.
Oh, wow.
In visual scripting. So
this must be explored now.
I know it's a big announcement also for the community, and we're happy to deliver this capability.
That sounds great.
Good to know. How can we assure robustness and parameterization with this cool visual scripting tool?
Well, this tool is technically integrated as any other the CATIA tool inside of the platform. So technically, you can use the same tool, and you can use this tool in addition to all the other tools that you're using. So technically, you can switch from GSD to Visual Scripting and back in the way as you're using it between other apps within 3D Experience.
So actually, Visual Scripting is creating CATIA traditional feature or advanced feature, but still full compatible with the rest of the app.
Correct. You will get the results, which then are in some kind of geometrical objects, which then can be reused by other tools. So technically, they are the same type of the objects.
And also, I think, Tomislav, you were showing that, but there is a lot of additional operators to manage some exceptions, some errors, to be able, in fact, to create some rules to avoid any failure during the update. So by default, when you do something in Visual Scripting, you are creating a robust algorithm.
Correct.
Okay.
Correct, because we can anticipate all the errors that are going to happen, and we can simply filter them out.
That's powerful, huh?
Do we have other questions?
Okay, so if there is no more question, let's go on. So let's conclude. So thank you for joining us today for this CATIA Design Talk. A special thank you for our guests, Tomislav and Edouard, for sharing this use case and their insight with us. We hope you find this webinar informative and engaging and inspiring you exploring new possibility in industrial design thanks to the CATIA and the Visual Scripting app. Remember, so you can watch the replay of this talk on our CATIA Creative Design and Styling community. The links will appear on the screen, at the bottom of the screen, and we continue the conversation. You can continue the conversation with Tomislav and Edouard as well on the community. Simply register and gain access to all our insight and best practice, and it's free. We appreciate your participation and feedback. We look forward to seeing you again on our next CATIA Design Talk. And until then, have a great day and keep innovating with CATIA. Goodbye.
Bye, everyone.
Bye-bye. Thank you for having me.